Hi, welcome to Tech Ranch, a place where we learn and earn technical skills in the most efficient way. Let's make coding fun. Java Exercise Series 1. In this series, we are going to share a practice problems for Java. So objective of this series is to practice core Java concepts and fundamentals in detail. So far we have learned in core Java series about control statements and arrays. So to practice these two concepts in detail, exercise 1 Fibonacci series. In this session we are going to learn what is actually a Fibonacci series, the logic behind it, the concept and the formula, the pattern, the solution and the practice. So what is Fibonacci? Fibonacci sequence or series is a series of numbers in which each successive number in the sequence is obtained by adding the two previous numbers in the series. So basically Fibonacci series is, in the simple words we say, the next number is found by adding up the two numbers before it. To understand it better, you can take a look at this one. This is the series, and here the first series is 0. It starts from the 0 and the number in this series is 1. So to get the next number, we have to add 0 plus 1. You see? So the next number is going to be 1. Now this one is going to assign to the next number, and these two numbers in the next iteration is going to add it again. So next time the first number is going to be 1 and the next number is going to be next one, and we are going to add these two ones and get it 1 plus 1 equals to 2. Now this number 2 is going to assign to the next here. Now this time in this iteration the first number is going to be 1, the next number is going to be 2. Now 1 plus 2 equals 3. So this is how it works. Next iteration, number 1 is 2, next number is 3, 2 plus 3 equals 5. So the next number is going to be 5. So this is how it is working. So basically the formula or the pattern on the logic of Fibonacci is Fn equals Fn minus 1 plus Fn minus 2. So this is how it works. The last two numbers of addition will give you the next number. Now the basic pattern, the logic of Fibonacci is being used when we work with exponential or any kind of pattern or behavior of a system we learn. So in case of Fibonacci pattern, we named it as a spiral form. If you see this image, here it makes a spiral. So it based on the axis, if you see the axis x, y and z, here it starts from 0 plus 1, 1, then 1 plus 1 is 2, then it's moving forward, 2 plus 3 equals to 5, and it's expanding the pattern of the spiral. So you see the pointer is moving far and expanding. So the last two numbers, in addition of the last two numbers, the result makes the spiral bigger and broader. So this is how the spiral pattern made it with the help of the Fibonacci logic. And this type of pattern will explain and gives you the growth of a system and the behavior of a system. Now how does it work? Let's take a look at the logic. The Fibonacci sequence is a logic, is a pattern which can be implemented with number of ways. So far we have learned do while or for loop, for each loop. There is another kind of iteration control statements is called recursion. So Fibonacci using recursion. Now before we start with the recursion, you have to understand what is recursion. So recursion is nothing but the self and automated iteration loop. So what is happening within a loop, if you call that loop, is called recursion. Now let's take a look. It is the best example to understand here. So let's take a look at this code. Static int n1, n2 and n3. These are the initial numbers we consider. Now fib is a method where we have the count. This is nothing but the limit of the series. Now count is greater than 0. This is the if condition, and n3 equals to n1 plus n2, and n1 equals to n2 and n2 equals to n3. So in the first iteration inside the compiler, how it works, let's take a look at here. n1 equals to 0, n2 equals to 1, and n3 equals to 0. So in the first iteration, since count equals to 4, which is greater than 0, so this series will go like this: n1 0, n2 1, and n3 is 1. Now when the n3 calculate the n1 plus n2, this will be 0 plus 1, so this will be 1. Now the recursion comes here with this blue arrow. If you can see, this will method recalled himself because the condition is still true. The count is now reduced to 3 since it is n minus 1 in the end. So the count is 3 now. So in the next iteration, if you see, the count is 3 and n1 is 1. The pointer has moved from 0 to next index of an array or a list or a series, and n2 is 1 and n3 is 2. The count equals to 3. Now condition is still true. So n3 equals to n1 plus n2 is 1 plus 1. This is 2. So n1 is 1, n2 is 2, and n3 is 2. Now 3 minus 1 count is equals to 2. Now let's take a look in the next iteration. Now count is equals to 2, n1 is 1, n2 is 3. Now in this condition, the true count 2 is greater than 0. So this time, since n1 plus n2 is 2 plus 1 is equals to 3. So n3 is 3, n1 is 1, and n2 is 2. And count is still greater than 0 because 2 minus 1 is equals to 1. Now count is 1. So in this case, this recursion method is again being called. So in this iteration, as you can see, the last iteration equals to 5 in this iteration. Since n1 equals to 2, which is plus 3, that is 5. So this will print 5. Now after this iteration, since count minus 1, it becomes 0. That means the condition is false now. So it will return an exit and print all the series. So this is how it works. After all this recursion in Fibonacci, this will come up with this kind of behavior of a system and print the spiral in the axis. Now based on this kind of logic and algorithm, the complexity is mentioned in this form, mentioned in the Tn equals to Tn minus 1 plus Tn minus 2. Since we add the last 2 digits or last 2 numbers in the series and give the third number, and that's how it works in a Fibonacci series. So for practice, try to implement using these type of algorithm using do while or for loop or while loop. Now let's take a look at the demonstration for your reference. So let's take a look at the execution of Fibonacci. So first thing we need to have the class Fibonacci, and after this I'm gonna make, since we are going to do it in recursion, so we need to have a method, and you have to first decide how you want it to implement. So for now I have shown you in the example in a recursion form. Now let's take a look in the form of for, just for your reference, that you can practice in your homework. So here is my method, and in this method, first need I want the first number, or you can give int a equals to 0, my second number b equals to 1, and c my third number, and my I for loop. Now Since we need a limit, so what we can do, we can use scanner. This will help you to get the integer limit of the series. Since it's showing error because I need to import the util package. So once this is done, then what we need to do is we need to get the integer, we need to get the limit of the sequence from the user, and that will be your count in dot next int system print. Here first we think we need to print our first numbers, first 2 digits, which will print your first values. And now let's start from the loop. Since first 2 digits is already mentioned, so we'll start the loop from 2. I is greater than count. Now here we need to give the condition which has to be greater than count. Now increment of I for the loop start from 2 to 0 and 1, which are already printed. Now within the loop what we have to do, we have C equals to A plus B. Now system, we have to print your digits C with some space to clearly display. So A equals to B, B equals to C, so that the pointer move to the next digit and it will print the value. So this is my method I'm implementing using for loop. Now let's get the main method. This is very simple. You can use recursion, and here let's make first class object and call the method, and once this is done you can just terminate it with a new line. Now let's take a look at the execution. So you need to first give the limit. Suppose I give 8, so you can see here. So let's take a look at the execution now. Suppose I give 10. So as you can see, 0, 1, 1 is equals to 2. 1 plus 2 equals to 3. 3 plus 5 equals to 8. 8 plus 5 equals to 13. 13 plus 21 is equals to 34, and so on. So all you need to simply give the limits and it will print you the series over here like this. So this is called the spiral behavior of a system in the Fibonacci logic. So far we have seen the execution of Fibonacci using recursion and for loop. For more practice, you can try to implement this kind of series implementation in do while, or for loop, or while loop, or recursion implementation. In the next session in this series, we are going to learn about factorial implementation. So stay tuned, and thank you so much for watching this video. Please subscribe to our channel for more upcoming interesting videos. Let's make coding fun. Thank you.